recording. Okay, so let's get started. Today we are in chapter 13. We are in the second half for this algorithm and recursion design. And we finished a few sorting so far. So next one would be merge sort. Okay, so the idea of merge sort is like originally I have a list. So I break down into two. Okay, break down into two. And then I break down into two again. So that becomes four group. And then each group I break down into another two. Okay, until it only has one element, an element each. And after it's broken down into one element each, then we actually combine them by adding the smaller one in front, larger one at the back. Same thing, every one of the group, smaller one in front, larger one at the back. And then we start to combine two of them together. So this one 4 first, and then 14, and then 25, and then 31. So small one go first, large one go last. Something like that. And here we combine everything back. So this is called merge sort. So far, is that okay for this merge sort? Yeah?
Yeah.
Okay, so let's do it, okay? Now you know what's merge sort. That's the fourth sort we talk about. This one considered to be a little bit more difficult, but I just want you to have an idea of what is merge sort. Okay, everything here is actually beyond what you need to know. It's all already, these different topics already in the AP or even college level. So you don't need to know everything if you're not able to understand. So I set up with some array with random order. Okay, so that's some random order, and would like to try to solve it. Okay, and at the end of it, I'm going to actually print out my A array. Okay, so some sorting needed, and I'm going to put them into order. Okay, so here first things like I need to define some function called merge sort. Okay, so merge sort. I'm going to divide, actually do merge sort. So I will actually get a array. So here I say I've got an array or list coming in, right? I actually get some array or something that I get, okay? And then here actually I will do what? I'll do, I will say do what? I will have some integer called low. So low will be actually will be the arrays, that will be 0. And high will be arrays length. And then -1. So what are these? What are these two different things? This actually is, I have a list, right? So 1, 2, 3, 4, 5. So this low is here, high is actually here. Okay. You can use that, and then you can calculate the middle point. So middle point, last time we calculated, right? Remember for a binary search? Middle point will be where?
Middle point is in
half of the low plus half.
Yeah.
Right?
Yeah.
So your 5 element, it will be this one. If 4 element, it will be toward the smaller side. Right? Remember that? Is that okay so far?
Yeah.
Okay, then actually I need to calculate something called mid. So midpoint is half of my low and high. But remember the division need to be integer division, so divided by 2. I get low and high. So I would have array 1 that actually will be returned from my merge sort. Which portion I should run here? It will be my merge sort here will be my merge sort. I started from actually low. It should be my array ARY. No, should be my, let me see, my ARY. And actually here should be what? Let me see. Here I should call a merge sort. Let me see. Here I should say my merge sort. Here I should put what? Low and high. I'm sorry. Here should low and mid. Okay. And the other one is A2. There's A2, and it actually is merge sort. And it has ARY, low plus 1, no, middle plus 1, and high. Okay, and here would have, let me see. And here would have, I would say I will merge, I will return merge of what? Merge of A1 and A2. Okay, and here if the array is if ARY length of the array is equal, if less or equals 1, what should I do? I will just return my array. So if I down to 1 element or 0 element, then I would actually just return that array. Is that okay? So I keep breaking things down, but if my array already down to only 1 element, I basically just return this one. So I return this one, and it will return to where? Return to here, A1 or A2. I break down this into 2 parts, from low to mid, and mid plus 1 to high. All right, so if there is A element, okay, so if there is an A element, I have like 5, 2, 3, 1, 4, 9, 8, 7, okay, something like that. So I will actually break down into 2 parts, 5, 2, 3, 1, 4, 9, 8, 7. So this one is the A1. But A1 need to be sorted, so this is not done yet. So this one will further break down into 5, 2, and 3, 1. Okay, and this one will break down into 5, 2, and 3, 1. And 5, 2 would combine back to 2, 5. 3, 1 combine back to 1, 3. And 2, 5, 1, 3 will combine back to 1, 2, 3, 5. Right? So in this side, you break down to 4, 9, and 4 and 9 and 8 and 7, 2 or 4 of them. And then you will come back to 4, 9 and 7, 8. And then this will combine back to 4, 7, 9, 8, 9. And 4, 7, 8, 9 will combine with 1, 2, 3, 5. And you will get 1, 2, 3, 4, 5, 7, 8, 9. So that becomes sorted. Okay, so here, when I actually break down 2, it actually breaks down into 2 parts. Now for from low to mid for array 1, and it will sort this one. It will sort this one, and the result will be returned to here. So when this one back, it will return. And when it go to 5, 3, 2, 1, you break down to 5, 2, and 3, 1. That's the new low and new high. And actually, it will first go down to 2, 3, 5, 2. And once you hit the 0 or 1 element, I just return the array. Okay, I just return the array. Otherwise, you continue to break down them. And later, I need to merge. So I need to write a merge sort algorithm and something like that. So here, actually, let me clear this one. So here, I would take back. Here, I would actually take back. This one, I would actually have my integer should have my LL and high. Okay, so when I take this one in, I should have what? I should have, actually, I should have something called, here I should have, this one should be my low, and this one high should be my high, okay? It would be something like this, okay? And you need to actually merge the two, okay? So that there are two array and that need to be merged, okay? The two array need to be merged. So I need to write some function called merge. So merge. So I would have array 1, and I would have array 2, and I need to merge these two arrays. Okay, I need to merge these two arrays together. So I would actually merge the two arrays, and I would actually have something called P equals 0. I have Q equals 0. I have R equals 0. Okay, and then I would have array 3 equals empty array. Okay, so I get first array and second array, and then I would create a third array. Okay, and what's that? My first array is called A1, the second array is called A2, and I'm going to combine the two together. So I have array 1, I have array 2, and here maybe 5, 3, 8, here maybe 4, 2, 9, okay? So here actually, after sorting, it should be 2, 4, 9, this should be 3, 5, 8, and then I'm trying to merge these two. So 2 go first, and with 3, and then 4 come in, and then 5, and then 8, and then 9. So smaller go in first, okay? Smaller go in first. So I should combine the two arrays, smaller go in first. So P, Q, R are 3 pointers. So while P, it actually length of array 1, and the Q length of array 2. Okay, I continue to do this because what are we going to do with merging? So again, here if we have this one 3, 5, 8, and here we have 2, 4, 7, 2, 4, 9, right? So this length is 3, this length is also 3. I started from 0, P started from 0, Q starting from 4. So I compare starting from 2. I compare these two numbers, 2 is smaller, so 2A into the array A3 first. And R is pointing to here. R initially is setting to here. So what I'm going to do here is, so if A1's P element is less than equal to A2's Q element, then what? My A3's dot append, I add my since in here, my A3 append with A2, actually A1's P value. Okay, and then my P increased. Okay, and actually this R is none required. I don't need the R, so it's okay. Okay, I don't need the R. And then if not means that A2Q will be smaller. Then in that case, I actually will do this. I do A3 append, and I do A2's Q value, and then Q will be increased. Okay, so what happened is like, I find out 2 is smaller, so I add my 2 to my A3, and then my original, my Q is pointing to 2, and now I move to here, so Q need to increase to by 1, go to 4. Okay, and then actually it's 4 compared to 3, so my P actually, this A1 is smaller, so 3 put here, but P move from 0 to 1 to pointing to 5. Okay, and then next one I compare P and Q4 is smaller, so my Q move on to 9. And next one 8 is smaller, so I put A in here, my P move on to 8. I'm sorry, 5. it compared with the 5 and 9, actually 5 is smaller. And my P move on to 8. After that, I compare 8 and 9, my 8 is smaller. So I put my 8 in, and then this one out of bound. When this one out of bound, get out of bound, then it actually understand it become equal or greater than some A1. Then this loop get out. But array 2 still have remaining elements. So what I need to do is, first thing is like, so if that get out and I say, if my P still less than the length of A1, then I'll do is, what I'll do is A3 dot append my A1's P value, and my P will increase. Okay, same thing if my Q's value, actually my Q has not been used. Some Q has not been used. Then again, I will do A3 dot append here would be what? Here would be my A2's Q value. And then actually my Q will increase. Okay, so that I add 2 array together, merging together. And after that, I finish everything, so I return A3. My A3 combine the 2 array. So I just return that. And that finish my merging portion. So my merging portion, I merge things back, I put in back. And at the end of this, I return the merging things over here. So my A will become my merge sort of A0 and length of A minus 1. Okay, and then I print out my A. So I need to actually print out my A before merge sort, and then I print out my A after the merge sort, and let's compare. See if this works. Okay, let me see. Here has a return ARY. Recursion, what's that? Here, let me see. Let me see. Oh, I shouldn't. This one is wrong. This one is not ARY. It should be an array. Here should be an array of what? This array is less than 1. So here should be an array of ARY of low will be enough. Okay. The single element need to be returned. Okay. So that actually is fine. Let me actually do this now. The remainder here, let me see. So here, let me see right here. Let me see right here. It actually repeat too much. That's too many recursion. So here, when I get in here, less than equal to 1, then return. So let me see. If the array is actually less than or equal to 1. Let me see. So here, at least when you go in, let me actually do printing of my array. See what happens. So my array is the same. It runs many times, should be the same. And actually what's happened is it's not really returning anything. So let me see here. I don't need to, I comment this out. And here I print out my A1. And here I print now my A2. See if I see the A1 and A2. So here actually never go to the A1, A2 return. So once you go into the merge portion, it actually start to work. Okay, let me see. So here I enter here, I merge here. So let me actually do this. Let me do this one. A3, A2, append this PQ, PQ. Let me see. Okay, here let me print out my A1 and print out my A2 over here. Okay, let's run it. You never go down to here even. Let me see. Let me see anything wrong on my algorithm. Let me check the code here. So this one, while this one, it doesn't, it actually, this one, 1, 2, 0, 0, 0. And this one, less than 1 and 2. So here it actually while less than n1 and 2. Okay. This is end condition. I3 need to be increased. No, this I don't care. This 2 I don't care. Okay, so let's do this. Okay, let's do this. Because I don't know whether merge is wrong or something is wrong. So let's do this. I don't do this merge first. Okay, I don't do this merge first. Let's just solve first. Let's just try merging. Okay, here we want to debug. So let's do print out of my merge of something like 358, comma 429. Okay, the example I have given. So this one I just run an A. I don't want to print now. Okay, so this is the way I debug the merge part. So this merge part, if I merge it, no, the 2 actually is not in order, right? It's not in order. It's not really in order. So basically, oh, it need to be sorted, right? So here, let me see. It's a 358, and this is actually 249. Let me try this one. This one's 249 sorted. These 2 need to be sorted. Okay, this one merged right. Okay, now the thing is like, do my merge sort actually really it has a low and high come in if the length of that array is the length, and then that's not trying this one because the length never be less than that. So let me try actually if that length is actually equals the height or height is less than. So let's assume that here if I have height less than equals height. Okay, probably this is the problem. Okay, probably this is the problem. So now let me close the merge portion. Okay, open the merge sort again. I think that's the problem. Okay, because actually I did not take care of the 0 case correctly. So what? So I get a single 8. The A, I get a single 8. So here, let me see. If my length and height, oh, okay, here I have low is this, high is this one. And low actually is greater than or equal to high. Okay. So that is the wrong thing. Okay, let me try again. Okay, so this one actually correct now. Is that okay? So when there's a crossover, my low power greater or equal to h, low power equal to h, that actually is only single element. If my low is greater than high, that's crossover. Crossover means my array, that the part that I want to break down has no element anymore. Is that okay for this one? And it actually break down the whole thing. So here now I don't need this print now for A1, A2. Okay. And then here, let me actually run it again. And it print now everything. Let me see the merge portion, the merge sort, low, low, high, high. And this merge portion, oh, here I print now. So here I don't need to print now. I close this, okay? And run again. Okay, so it sort everything into one shot. So that's the merge sort. First, you have the array, and I know which part, like my low part, my low index and my high index. So for example, I have an array, right? Originally, I have 8 elements. So first time I 0 to 3, 4 to 8, 4 to 7. My 8 element first time I sort on this. So low will be 0, high will be 4. Okay, and then I break down into low will be 0, mid will be 2, will be 1, right? Mid plus 1 will be 2, high will be 3. Then I break down into 2 portions, and this one sorting by A3, A1, and A2. And my 0 and 1 actually break down into 2, so index will be 0, 0 for 0 get in, and then 1, 1 for 1 to get in, something like that. So that only single element, so it start to combine back. So it start with these 2 break down to these 2 and these 2, and these 2 break down to 0, index 0 and index 1, and this one started for index 2 and 3, right? And then this one combine back to 0 and 1, combine back to 2 and 3, and then combine back to 4 element. Is that okay?
Yeah.
Okay, so that's what it is. And that's the merge sort. Okay, so this one definitely more difficult than the 3 sort we talked about before, right? Like a little bit not that easy. And it requires the recursion. So make sure you understand it, okay? Make sure you understand it. So here, let me save this one, save all. Now the next one is another sort called quick sort. Okay, quick sort. Quick sort is divide and conquer. Divide and conquer. So what should I do? What I am going to do for quick sort would be, quick sort needs something called pivot. Okay, what's pivot? So if I have so many elements, say I have 0 to 8, right? So I will use the 0 element as my pivot. Okay, and I break down into my array from here, from 1 to, say, here actually here is 1 to maybe 3. 3, let me see. 3 is the middle, right? And then 4 to 8, okay, something like that, okay, whatever. And this portion, I actually will actually, no, I'm not doing that. Actually, I use this one as a pivot, and then I would say, whoever bigger than me, put on the right side, left side, smaller than me, but put my smaller side, okay, and then I combine things back, okay? So that's the idea. That's the idea for pivot and quick sort. Okay, so you put something greater than you. So here, first I use 5 as a pivot. So I put 5 in the middle, and then set anything smaller than me, put on the left side, greater than me, put on the right side. So the second time I use my 6 as a pivot for 5, 9, A3. And then I put whatever smaller than me, 5 on my right side, on my left side, 987 to my left side, and then combine things back. And this side I use 1 as a pivot. Anything smaller than me, put on the left side, greater than me, put on the right side. Okay, and combine something like that. So that's the idea. So this A array, I'll still use it. And here I will say, I knew a program. Here I'll say it called quicksort. Okay, so this one's called quicksort. So quicksort, I have this one, and I will call something called define a function called quicksort. Okay, and quicksort, I will take back a array called A, right? And I will do what? The return, right? Return what? Return a list, right? Plus a list of my A 0, and then plus a list of two lists, okay? Two list. This portion is for x in A if what? A of this, let me put this I, okay? Let me see, in x in A, if AX actually less than my A0, okay? And here for Y, for Y in A if my Y greater equal. So greater equal, I'll put on the right side. Okay. Okay, and then print quicksort of A. Let me see. This one AA7. No, let me see here, A0. I print out my A. Oh, let me see here. No, here I should have my, it's 1 to the N. So this is not really A. This one should be 1 to the N. 0 is not included. Okay, 0 is not included. Okay, let me put a 0 here, put an A again. So what's wrong with this one? Actually, let me see. For I recursively calling it, let me see. So here I need to put, quicksort of this one. Okay, and here I need to call quicksort. Okay, what I'm trying to show you is like, I actually would like to finish this program in one line. Okay, finish the whole function in one line. Let me see. Let me see, would I be successful? No. Too many operations. So here, X, let me see, quicksort, it doesn't stop, okay? So here, let me actually do this. Cut this one and I say this one is A1 equals this one. I start trying it. So here if length of A equals less than equals 1, then I'll return A. Okay, otherwise I'll do this. Okay, and then A2 equals these things. A2 equals these things. Okay, and then I have my A1 plus that one plus A2. Let me see. Oh, this one. Oh, okay. So this one actually, what I need to do is my A need to be equals my quick sort. Okay. Okay, because it's non-destructive sorting, so I need to assign it back to my list A. And now this one should be working. So now this one should be working. Okay, so this one is okay. So basically, if the length is equals 1, I have nothing to throw to my left, I have nothing to throw to my right. So that list already okay, so I return it. Otherwise, anything less than me will be thrown to A1. A1 is a list, right? Anything greater than me will be thrown into A2. But I will sort that one first, sort my left side first, and then sort my right side. And then my left side combine with my A0 and my right side compared to my A0. Is that okay so far?
Yeah.
So the idea is like, give me an array, right? Give me an array. So initially you may be like 5, 3, 4, 2, 7, something like that, right? So first run my 5 is over here, and I throw my 3, 4 over here. No. My 3, 4, 2 over here, and this side I throw my 7 over here, right? And then second run, actually, I use 3 as a pivot. So 3 over here, I use throw my 2 over here, my 4 over here, right? And then this side, I only have a 7, so 7 return already. So 7 return and plus with my A0. And these two return already, so 2 return already. 3, okay, 4 return already. Okay, and after that, this one, and this one, these 3 combine together to get your final result, 2, 3, 4, 5, 7, something like that. I can further reduce it. To get a single line. So here, let me actually call define quick sort. And then here I will say A. So here it's called quick sort 1. Okay, I can write it into one line. Return. So return A. Okay. If here, if length of A less than equal 0, little 1, and then else do what? Else do this one, else do this one, quick sort, copy here, plus A zeros plus A2, put on this here. Okay. And then that's it. Okay, then that's it. So let's do this. Okay, here actually, I just want to show you that this can be done in one single line. no, here I should do, let me see, A got sorted, right? Here I should have another one. I should have a B equal the same thing. Okay, B equal the same thing. Not B equal the same thing. Okay, so here I would say print my B. And here I say my B. And I assign to my B. And then after sorting, I print out my B. So here print out my B. Okay, and here I actually need to print now my A. Okay, so it's A and then A sorted B and then B sorted. Okay. Okay, and it proves you that this quick sort can really be done in one line. Okay, it's really one line. And it actually can still do this one. Okay, let's do this one. Really one line. It's actually really officially one line quick sort. Okay, so if you understand quick sort, what is the feature for quick sort? Ryan, what is the quick sort? It's the shortest call ever.
Sort?
Yeah, quick sort is the shortest call ever, right?
Yeah.
It actually is the shortest call ever that you can do. Okay, it actually, in fact, is the shortest call you can do. And it's just one line. One line you can solve everything. Other sorting, you know, it's so far it actually writes several lines and still be very difficult to use it, right? So it's okay for this one. And then single pass is a single pass quick sort. I show you already, right? And choose a pivot, whatever. You combine, so you put 5 and then whoever bigger than me throw to the left side, smaller than me throw to the right side, and I use 1 as a pivot, right? And then everything on the right side, I use 4 as a pivot, right? And here I have 2 and 3, 2 and 3. Okay. Here I have 7, whatever less than me put in the left, and then bigger than the right. Okay, something like that. So you get things sorted. Okay, so that actually finished the quick sort. And that's the quick sort over here. Whatever, there are several versions, but I think it's all the same. And then here is an analysis of different sorting. In this chapter, we primarily on the sorting part. So the different sorting, here have different growth rate, okay? And it's like a polynomial. If it's the order of n square, would be slower, and n log n actually is faster. Merge sort, quick sort, all have the best case n log n, worst case n log n. I would say quick sort, worst case n square. Okay, so quick sort worst case is not good, but quick sort average case and best case is good. Okay, and usually the standard sorting is using merge sort, but it actually takes more space than other sorting. And bubble sort, insertion sort, quick sort, selection sort, they are just for demonstration purpose. Real sorting rarely use this different sorting unless that you write your own sorting. Otherwise, it's certainly used. Okay, and you can compare different sorting who is faster. So most of the case, insertion sort is the slowest. Okay, and then merge sort, quick sort slightly better than merge sort. Okay, but the worst case, merge sort is not as good. But on the average, quick sort is actually better than merge sort. Okay, that's a big old complexity. And then the last one is the Hanoi Tower, but we actually don't do this one because it's too complicated. The only thing is like, in order to move Hanoi Tower, from here to here, you need to put this. If this is 1 level, 2 level, 3 level, 4, 5, 6, 7, 8. You put 7 level, 8 level. You need to first move 7 level to here and move the base to here. And then 7 level, you need to move this one to here, 6 level to here, and move this one back to here. So it's something like this. If I have 3 level Hanoi Tower, right? And I want to, from A, I want to move to B, right? So first thing I need to do is like, I need to erase these two and move it to C first. Then at that time, I move this one to here, right? And then I take this out, I move that one to there. Now I'm going to move my C to, now I'm going to move my C to B. So I need to move this single block to A first. And then I take this one to here. And then I erase these two, right? So on the next one, actually, I just move this one back to here. Okay, so recursively, I actually will be able to move everything to B if B is my destination. So first, I move my, say I have a 3 on A. I need to move my 2 to C. C is the spare one. And then I move my last one to B. That's it. And then later I need to move my C back to B. But in order to move C back to B, I need to move my one block to A and then second block to B, and then move my top one to B again. So that's the program we will do. But here I don't want to show the code. It's so complicated, but that's the idea. Okay, so here if it's 3 level, it's the step-by-step analysis. Okay, and that's it. That's for the Hanoi Tower, but we don't go into that. And these are whole team problem, make no sense. Turning machine too much. So we finish chapter 13 and do exercise 147. Any question for today?
No.
Thank you.
Thank you. Bye.
Bye now.
Bye now.